Yes, that is a tangerine.
Is that really so much fun?
Wouldn't the gerene cancel?
Yeah, I don't know where I got the picture.
Wouldn't the
Once again, does sine of theta over cosine of theta, does theta cancel out?
Yes.
So I want to look at the graph of tangent x. And just like we did the other day about sines and cosines, the easiest way to graph tangents is to once again talk. It's 1 and 2, they're all mixed together. Yeah, 14.1 does all the parent functions of sine, cosine, and tangent. 14.2 does all the shifts. I like to separate sines and cosines from tangents because tangents are completely different than the other two. I have to do them all on their own. So when we graphed before, we graphed things via the quadrantals. So we had 1, 0, 0, 1, negative 1, 0, and 0, negative 1. But tangent's like the dance. I love it. But tangent is always going to be equal to your values of y over x on the unit circle. So what we do here is we look at it. We look at it in terms of if you go through the whole cycle. Tangent at 0 is what? It's 0 because it is y over x, 0 over 1. Bless you. Tangent at pi over 2 then is 1 divided by 0. Bless you. What is 1 divided by 0? No. We say no, we say undefined. So therefore you get an asymptote. If I continue on and I go to tangent at pi, I get 0 again. You okay with that? And then if I go to 3 pi over 2, I'm back to an asymptote. Because what's negative 1 divided by 0?
Why is it a negative 1?
Where?
Like at the 3 pi over 2, why is it negative 1?
I'm just doing the quadrantal ordered pairs.
Oh, okay.
Remember x and y, cosine, sines?
Okay.
Tangent, sine over cosine, hence sine gerene, cosine gerene.
I should have shown that to my dad and said that's easy.
And then back at 2 pi, it's back to 0. So if you look at the way tangent breaks down going throughout the entire round of the unit circle, you get breaks within the asymptotes. I also want to show you what happens. We also know a very easy value for tangent. We know tangent is always going to be equal to 1 at our pi over 4s. Remember, at 45 degrees tangent is 1 over 1, so it's always 1. It's just positive in 1 and 3, and it's negative in 2 and 4. So I know that at pi over 4, it's 1.
So that's what I did.
At 3 pi over 4, sorry. Yes, and I'm going to, you'll see in a second. At 3 pi over 4, is tangent positive or negative? It's negative, so it's at negative 1. The next one would be, was it 5 pi over 4? And I'm back to 1. And the next one would be 7 pi over 4. And I'm back to, where am I at? Negative 1 again, sorry. Now, when you have asymptotes, that means you're getting infinitely closer and closer and closer to something, but you don't ever touch it. So, in between here, we know that tangent is increasing from left to right. doing this. And it's doing this from here, and it's doing this from here. Now, what happens is that we don't graph tangent always to look like that, because it's messy, and we don't need to worry about tangents being between 0 and 2 pi. Because if you look at between 0 and 2 pi, it's been replicated twice. Bless you, the graph has been shown twice, hasn't it? You all right?
You just made me feel like it.
Huh?
Because earlier Lou sneezed and then Serena sneezed. And I was like, Sarah, you're going to sneeze next. It's stupid, I'm sorry.
They sneezed.
And what if this person, are you gonna sneeze? Everybody else is sneezing.
She started.
So, is everybody okay with saying that in this case, our graph, our dancing graph, has been replicated twice within one revolution of the circle?
Sure.
So what we do is, if you look, the entire graph is shown between pi over 2 and 3 pi over 2. How far apart are those asymptotes? 1 pi. So what we do here is we disregard all of this, and we back it up to look at tangent to only go between the asymptotes, positive and negative. Tangent's one of the ones that we set up on both sides of the origin. So when we graph tangent from now on, what we do is this. We take our middle. Tangent will always, always, always go through the origin, because at 0, tangent's 0. Tangent, a standard y equals tangent of x, will always have asymptotes at pi over 2 and negative pi over 2. The asymptotes, remember, asymptotes are written as x equals pi over 2, x equals negative pi over 2, because they're vertical. We okay with that?
Sure.
The distance between these two asymptotes for our generic start of a tangent is the period. In this case, that period is how long? 1 pi. Okay? The asymptotes are garner up one period of the tangent. We know tangent goes through the origin. We know that tangent equals 1 at pi over 4. And we know that tangent equals 1 at, or excuse me, negative 1 at negative pi over 4. So this is all we need to do to graph tangent, is use those values. We don't have to worry about going to 2 pi with this and just show a little half here and then the rest of it in the middle and then a full one in the middle. We just worry about one section of it. So we're only going to look at, in this case, one period of tangent.
Just like the one thing for cosine and sine, if you look at the one thing.
And that part was one full oscillation to get back and forth, or here, tangents, full, I don't want to say oscillation because it's not an oscillation,
One
but
full
tangent,
dance move.
one full dance move is just between negative pi over 2 and pi over 2. And then we'll just adjust it accordingly with our b values and our a values and all that other stuff. But you get one full dance move between your asymptotes. Your dance moves might be longer, your dance moves might be shorter.
So I just said your dad's gonna
My dad does.
Okay.
I think
So then you get, this is how we're going to set this up from here on out. Not bad?
Sure.
So let's talk about the parent function. I'm going to say our a value like we have been earlier. We've been calling our a value an amplitude for sine and cosine. That a value told you how high up the curve went or how low the curve went. Well, in tangent, the height doesn't matter because it's infinite. It's a non-continuous function because of the asymptotes, but they're always increasing or decreasing. So what happens here is this amplitude-ish, I'm going to call it, is that breakpoint on the y-axis of where it changes direction. Okay? Think of that as that the breakpoint between origin and asymptote. Okay?
So the artist where that would be from the other way.
Think of it as at the height instead of the 1. So here, my A value is 1. That's all it is. It tells you where that value on the y, where your y-axis is going to be at. Yeah. Yeah.
Because then 0, 0 would be the chest.
0, 0 will be right here.
Yes, it's your elbow,
Okay.
your chest, and your elbow.
This is actually really cool.
Okay. So it's not technically the amplitude, it's amplitude-ish, if you will. This B value is going to help us determine the period. Well, the period of tangent graphs is always equal to pi over b. It still means the absolute value of b, but I really don't think I will ever have to worry about a negative b value in algebra 2. I think we'll throw one of them or so at you in pre-calc, so I don't have to worry about it. Oh, also A, if A is positive, you're dancing up. If A is negative, you're dancing down. You're dancing down, yes.
This is the best analogy I've ever come up with.
It works. Whatever happens, whatever works, right? It's like horizontal and vertical. It's stupid, but it works. What's wrong? Oh, what's up? I barely hit me either, so it's okay. Not bad? Let's walk through an example. Yes, ma'am.
Wait, I was gonna ask if you could do an example.
No, I'm just going to give you a quiz.
Wait, is that asymptote? So the period's like pi over b, not pi over b?
It's pi over b because our asymptotes in the generic tangent, just y equals tangent, is always pi apart. All right. Now, what does happen from time to time with tangent graphs is, guys, what happens from time to time with tangent graphs is that you do wind up with some pretty ugly fractions. But just remember, you're still just taking halvesies. Okay? Still working with halvesies. So here we have y equals 3/2 tangent of 4x. Just like we did yesterday, always start, or the past 2 days. What's your A? 3/2. What's your B? And after, which means your period, B4, bingo, B4.
Okay, Mr. Murphy.
Yes, ma'am.
What do you hear when a snake, a drum, and a no, wait, a sheep, a drum, and a snake fall?
Huh?
Should it be pi over 2?
It's 2 pi over b.
No. The period. Hey guys, the period for tangent is pi over b. Period of tangent. Period of tangent will always be pi over b. And I don't want to go into, don't worry about odd and multiples of this and all this other junk, okay? Period of tangent, remember your asymptotes occur at pi over 2 and 3 pi over 2. How far apart are those asymptotes? 1 pi. So all the parts of tangent occur in just 1/2 of the unit circle. That's why the period is just pi over b. All right, so here's what we do. We start this one knowing that our origin is going to be at 0, 0. We know that. We also know that our full period between the asymptotes is going to be pi over 4. So I'm going to have one positive and one negative asymptote. And I know that the distance between here and here has to be pi over 4. So half of it is positive, the other half is negative. So what's half of pi over 4? There you go. So your asymptotes are at pi over 8, positive, and negative pi over 8. Okay? Your breakpoints then occur at the halfway point between 0 and an 8, or pi over 8. What's half of pi over 8? Very good. Remember, this breakpoint is always going to be halfway between. Just remember how we had it asymptote at pi over 2, and then it was 0 at 0? It was 1 at the halfway point at 45. So the halfway point are the halvesies again to help us get all the rest of our breakpoints, both positive and negative. These two breakpoints, these pi over 16s, that's where your elbows occur. 3 halves, negative 3 halves. Do I have to mark it off at between 1 and 2, or can I just label it 3 halves? I just label it 3 halves. It doesn't matter. Okay? And is this one dancing up or dancing down?
Dancing up.
So we, oop, I didn't mean to put a dot here. There you go. What's that?
Well, they're already straight to the point.
In a roundabout kind of way?
Stop!
Tangerine, tangerine. It's a Led Zeppelin song. That's okay. Oh, let's just jump right to the ship.
Oh, shit.
No.
Maybe because it's 6S, but.
So the tangent shifted graph has the same generic look like the sines and cosines with your A, B, H's, and K, where H's move you horizontally, K's move you vertically. And just like we did before, we'll plot a parent function, your A tangent B, and then we'll just take those ordered pairs. Did you guys do okay by listing ordered pairs and just adding subtracting fractions? I thought that's a pretty easy way of doing it.
I just plot it on the graph. I just go 1, 2, half, half.
Sometimes it works really nicely, but there are times where your original and your phase shift might be.
I just have the first point and then I just like copy the rest. No.
I'll ask. I will ask that you guys label ordered pairs, so just so you know.
When you just say ordered pairs, like write out your pairs, but when it was easy, like it was really simple, I'd just be like.
I got you. So let's try one. Let's say it's y equals -2. Oh wait, how am I doing this? I'll just use the one they have here. And let's put on a +3 or something. So we have -2 tangent times the quantity x plus pi over 4, all +3. Your book would probably have written this as 3 minus 2 tangent x plus pi over 4. Remember, your h values will always be encompassed within the parentheses. K values will not be in a parenthesis. So let's list. What do we know? What's our a value?
-2, so it's gonna be dancing down.
A is -2. It's not a bad idea to show that right away that we remember. What's our b value? B value is 1 because there's nothing else written there. Our h value? Negative pi over 4. Very good. Since it's plus pi over 4, that means it had to been a minus a negative. So our h is negative pi over 4, which means what direction do we have to move our graph? Left. We're going to move our graph left. And our k value is 3, which means we have to go up 3. Can you move a vertical asymptote up?
Why not? Vertical S.
No, might as well.
Wait, are you legitimately wondering this? Or is it like
Shut up! I was trying to ask you something interesting. And you guys are like, whatever.
We're trying to make our minds explain.
Yesterday, I was asking a couple people about this. Have you started to realize as you learn where your things are being shifted to adjust where you draw it on your paper?
Yes.
Yeah.
Good.
No. Yeah. My homework was horrible. I'm sorry. I missed 2.
Notice,
I just kind of like wrote it.
I know that in this case, I'm going to have to move mine over to the right. I'm sorry, to the left. So I might draw the left side a little bit longer. I probably should have drawn it a little bit taller because I have to move up points and go from there. Parent function. My period here is just going to be pi, so that's going to be so bad. First thing you always want to place on the graphs are your asymptotes. So we're going to have an original and a shift. Our original asymptotes will be at, well, it has to be pi apart, so what will they be at?
Negative pi over 2,
Pi over 2 and negative pi over 2, very good. So I write it down, so it's pi over 2, oops. And the origin of tangent with no vertical will always go through 0. And then I'm going to have my breaks at negative pi over 4 and pi over 4.
Is it pi over 4 for the original?
Yes. I'm going to plot the parent function first, and then I'll switch and go to the shift. So my ordered pairs for the original will be at negative pi over 4, 0, 0, and pi over 4. A little tip, top tip for this, when you're putting your points in, put your points in as you would going from left to right. That way you know where they're going from left to right as you rewrite them. Go figure. So our a value was negative 2. That's why I marked off up 2 and down 2. This one we know is dancing down, so at negative pi over 4 it's going to be at 2, 0, and then negative 2. I've got my list of things. Parent functions, dotted or solid. Okay. Now to each one of those values, asymptotes included, I have to move everything left and up. So if I move a pi over 2 left pi over 4, where does it wind up? Well, what's negative 1/2 subtracted 4? Negative 3 over 4, very good. Negative 3 pi over 4. If I move pi over 2 over to pi over, move that left pi over 4, where does it go? Pi over 4.
I'm so confused.
Oh, so we're drawing new.
I can't look at my thing.
You put it,
do the graph.
that's okay. I mean, if you want to redraw, what I'm doing here is I'm putting in my asymptotes first. I moved everything. I moved my asymptotes left pi over 4 first.
Okay, but like the period's pi, right?
Yeah, period's still pi.
Okay, how come it's pi over 4 and negative pi over 4 then?
it's not negative pi over 4. Those are the breakpoints. It's pi over 2, negative pi over 2.
Okay.
Okay? So now, I know that between negative 3 pi over 4 and pi over 4 is a whole pi. What's halfway between those two?
Negative pi over 4.
Negative pi over 4. There's going to be my new origin. Or basically take this and subtract pi over 4. And then I move it up 3. So I'll start here. And when you do tangent graphs, these are the toughest one to redraw because you have so many asymptotes and dotted lines for parent functions. This is the one that you probably want to go off of your ordered pairs first, and then try to plot it as you go into it. Sure, by all means. So what's negative 1/4 minus a fourth would be negative 2/4. So this would be at negative pi over 2. 2 plus 3 is 5. Pi over 4 subtracted pi over 4 gets me to 0 and 1. And obviously not drawn to scale.
Yeah, I can tell.
No. Okay? And that's okay. It doesn't have to look really all that great because look at your ordered pairs. If the ordered pairs are right, as long as the graph isn't a sine curve, you're probably, that would be rather embarrassing. That tells me one of two things. One, you have no clue, or two, you copied off of somebody. Because you could have just made a curve and said, hey, who's got the right ordered pairs? And that's what we do. Not terrible? There's a lot, and yet you're gonna get. I know it's as long as you remember how to find period and all that. The graphing is just what it just looks like crap because there's so many dotted lines. That's the only thing. So. What's that? What's wrong? Negative pi over 2 and 5, negative pi over 4 and 3, 0, 1. Let me get the problems there. Do these, please. I got 6 tangents for you. Yeah.
Mr. Murphy, can you do an email about tomorrow?
Are you out too?
I'm like
Sure.
the softball team is asleep early.
Whatever. 8:45.
What?
That's fine. If we have anything, I know I was just telling her that I know I want to spend time tomorrow talking about how do you remember how you guys had those couple of problems the other day that said write a sine function given an a and a b value.
Yeah.
Well, I'm going to do write a sine, a cosine, a tangent function given a period, a phase shift, all that stuff. And what I mean by phase shift is your horizontal and your vertical, that kind of junk. So we'll work on that tomorrow. I've got a couple review things. What I'm kind of leaning towards doing with you guys is doing a Quizam question, whatever you want to call it, on just graphing, probably next Tuesday. All right, so we just all graphing on Tuesday. I'm starting to think that I don't have time to get to the reciprocal propertied ones. If we do, great, but it's not the end of the world. Then that'll get us to Wednesday of next week to start identities, and that'll take 4 days or so, which just kind of moves us up a couple of days, which is cool. Yes, ma'am?
Which category will this Quizam go in?
I don't know yet. I haven't decided.
Put it in the test category.
Might.
What is most statistical, like, your
Most procedural one.
Friday or Tuesday,
My
just.
tests are the best.
Yes, sir.
What is this?
I just said that.
You're better than me.
Yeah, we go back to regular school weeks.
What?